Hey, what's up? Let's talk about point slope equations. Okay, remember in algebra, point slope, it literally is telling you what the equation gives you. It gives you a point that's on our line and it gives you the slope of the line. Okay, so it gives you those two pieces of really crucial information. When we look, the point slope formula is y minus y1 equals m times the quantity x minus x1. Guys, anytime you see x and y, that's an ordered pair. It just tells us those are the points. If I know my equation, I can find any x and y that's on my graph, okay? This y1 and x1, that's just telling you that that's a totally separate point from the x and the y. It's just telling you, hey, we have two different points going on here, right? So this is going to be x1 and it's going to be y1. That gives you an ordered pair. Okay, so x and y, always thinking ordered pair, okay, in a table, in a graph, like that's where you would find it, okay? If we look at our notes, so we have our point is x1, y1, and it says the point will be opposite what it looks like in the equation. And we say that because we have these subtraction signs right here. In mathematics, negatives, subtraction, you're doing the opposite of what the true value is of that thing, right? So we're taking the opposite of y1, we're taking the opposite of x1. So our point is actually opposite signs of what the equation looks like it would be. And we're going to explore that. I'll show you the proof. If you don't believe me, you're like, yeah, right, you're crazy. I'll prove it. I'll prove it mathematically, show you what's going on. Okay, so we're going to look at these 5 equations and just practice. Can I identify the slope? And what point does this equation tell me? What's the slope? What point is on my graph? What's slope? What point's on the graph? Okay, so we're going to start with this first one. Okay, and we're going to look for slope first. Slope is that m value, just like in slope-intercept form. This is our slope. Okay, as long as this value is 1, okay, then our slope is whatever that number is outside. Okay. All right, so here we go. Slope. I'm looking for the m value. It's -5, right? I'm just going to go through all of these. Let's just find the slope first, right? So -5 on that first one. 2/3 is in that m spot here. So our slope on the second one is 2/3. On the third one, do you know it? Know it? -3/2. That's the m spot. Okay. Fourth one, -3 is our slope. On the fifth one, ooh, what number is out there? If you don't see it, if it's multiplication, because the slope times the x minus x1 quantity, right? So slope times, if you don't see the number in multiplication, it's always a 1. Okay, if you don't see it in multiplication, it's always a 1. So you can write that so that your brain's like, oh yeah, there's still a number there. It's not 0. Because if I multiply by 0, I actually would eliminate that whole right side. There wouldn't be anything there. It would just say 0. Okay, but we multiplied by 1. That leaves everything alone. Okay, so that's finding the slope. Slope, sweet, got it, cool. Okay, now the part where our brain has to stretch a little bit is with the point. Okay, so the point is opposite, and I'm going to prove it, but the point is opposite the equation. All right, so first thing I'm going to do is I'm going to train my brain how to read the equation, right? So I know ordered pairs go x, y, x1, y1, x1, y1. So I want to look at my equation where x1 is and where y1 is. And I'm always going to go x1, y1, not y1, x1. I'm not going to go left to right because then my brain gets all crazy and I'm like, maybe I write my ordered pair y1, x1. And then we're wrong and we cry sad math tears. We don't want to cry sad math tears. So we're going to label it in the order that I would write my ordered pairs. So x1, y1. Okay, I keep saying that it's opposite from the equation. So this looks like -2, but my pair, my point would actually be +2 right there. And then -6 would actually be a +6 for my y1. Okay, so there's our point. And here's the proof. Really quick, here's the proof, right? So I'm going to start by writing the original formula just so my brain is looking at what's happening. I'm going to use substitution to show you what's going on. And I'm going to plug in 0.26, okay? All right, so remember that's x1, y1. All right, so I'm only substituting in the y1 and the x1. So I'm going to do y minus, all I pull out, I don't take out the negative, that still stays in my equation. And all I'm doing is pulling out y1 and putting in the value that I said it is, which is positive 6. I'm going to put the sign in there to help you see the connection here. Okay, our slope here, it says is negative 5. And then I do x minus, all I'm substituting is the x1 and the y1. Everything else in my equation stays what it was. Okay, so x1 is positive 2, so I'm going to put a positive 2 in that place. All right, guys, look. When I subtract a positive, that's exactly the same as just subtracting the number, y minus 6. Look, I have y minus 6, okay, equals negative 5 times x minus a positive is the same thing as just subtracting it. So x minus 2, that's what I had on the right side. That's why it works mathematically. If I substitute in my positive points, my positive coordinates, because I'm subtracting, it ends up looking the opposite, okay? All right, let's try it again, because you're like, yeah, right, Miss Valente, you're crazy. That doesn't make sense. It does, it does, it does. Okay, here we go. Label it first, so I have x1, y1. Train your brain where to find it, okay? Always look back up at the original formula. Where was x1? Where's y1? Okay, all right, opposite of what we see. So negative 6, negative 2. So this point should be negative 6 because that's x1, and then negative 2. All right, let me prove it one more time for all the skeptics out there. So I'm going to write the original formula, y minus y1 equals m times x minus x1. Okay, we're going to use the point negative 6, negative 2 this time. Okay, there's your x1 and your y1. That's what we're going to sub in. All right, so all I do, I keep everything the same except for the coordinates that I'm substituting in. y1 is negative 2. Look, I kept that negative. All I replaced was y1. Okay, so our slope here we said was 2/3. I write x minus, because all I'm taking out is the x1, and I put in negative 6, because that's what the value is for x1, right? When we subtract a negative, that's the same as adding, right? Because this is like negative 1 times negative 2 plus 2, okay? Look, that's where we get the left side, y plus 2. On the other side, x minus negative 6 is the same as adding 6. That's where we get the x plus 6. So our point was negative 6, negative 2, but in the equation, look, it looks like positive 6 and positive 2. Opposite of what you see. The equation's lying to you. It's manipulating you. Don't fall for it, okay? All right, so here we go. Let's keep looking. x1, y1, opposite what I see, so negative 4, positive 1. So my equation is my point is negative 4, positive 1. Okay, on the next one, just over and over, training our brain what to look for. So x1 is positive 9. Ooh, there's not a y1. Oh no, we freak out. It doesn't work, Miss Valente, what happened? Guys, don't freak out, okay? I have y alone. Okay, so where did y1 go? What number would have been there that would just leave y? Well, if I do y plus 0, that would just leave y. So that must mean that y1 is 0, okay? Don't freak out. It's okay, it's okay. All right, last one. x1, y1, okay? Opposite of what we see, so negative 2, negative 8. Boom, boom. That's it, guys. So just training your brain. Point, slope. My point is opposite of what I see. Slope is the value outside.